Okay, so I'm going to try and explain, to my best of my ability, difference between the disk method and the washer method. So I kind of understand the disk method more, so we'll start with this. So basically, right here we have f of x, and so what we're going to do is we want to know what the area underneath the curve would be, so over the x-axis. So we're going to pretend like we're drawing the other half, and we're going to pretend like this is just a giant shape. So you can pretend that this is almost one big shape. So like it would look something like that, you know? But since this is a curve, like if this were a rectangle, we could easily figure this out, you know, the width and the height. This is width, this is height. We could easily figure this out if this were a rectangle, but it's not. It has these curvy things on it. So what we're going to do is we're going to break this down. Now a lot of times we'll see like our math teachers will put them in like 3 little discs. You can do 3 discs, but you know, the more discs you add, the better to be. So what you want to do to include all your discs is we'll just make the height of the discs, or like, I guess this isn't the height, but it's kind of like the little width of the discs. That's dx, because you see this part right here is this part up here. And then you'll also have the radius of your discs. Because we want to find the volume, right? And so pi r squared, missing a little square down here. Yeah, so it always confused me when teachers would just draw 3 circles, because you're really not finding only 3 circles. You're finding all of the circles all at once, which is kind of cool. So down here, you know, at first this looks really hard, but really this is just the pi, and then this is just radius squared. You know, it just looks big because they decided to put a big R instead of a little r. But I mean, and we can find the radius, like if this height is like 4, and I need a better problem in order to give you numbers. But yeah, so get the radius, and then we just times that by dx, which also sounds like a big fancy term, but that's really just like we're finding a shit. I should have figured this out more. But hopefully I'm making sense. We want to find the volume of the cylinder. And we know how to find the volume of a cylinder. There we go. I just forgot to put the H on the end. That's why I'm confused. So yeah. V equals pi r h. We'll keep trucking. And so we have the pi, we have an r, and we have the h. And these are just the bounds. So usually this will be like in between 0 and 4. So then our radius would be 2. And then it's basically the same thing for the vertical axis. It's just on a different, it'd be going this way. Okay, if that was a train wreck, let's go check out this one. Okay, so we got washer method. Gotta change my colors. So my drawing kind of turned out like crap, but basically it started out looking like this. But this is f of x. And then like we did before, we're going to pretend like we're doing it over the x-axis, and we're going to, but this time we have a hole drilled in the middle. And sometimes like on problems you'll see like the graph will look something like that, where this is shaded one thing, this is shaded another way, and this is what you're supposed to be finding. But I like better when you see them like this. So we have a hole down our middle. Okay. And so that's what I kind of try to draw over here. So if we pretend like this is one solid figure, and we've got these holes in the middle. And the reason why we use washers instead of discs is because washers have holes down the middle. So basically all we gotta do is first we'll pretend like they're solid. So we'll pretend like we got a solid circle, like we did before. And then, but we gotta take out the little hole part, because we don't want the hole. I mean, we need to take out this part of the hole. So first we find the solid, so f of x minus d of x. And then we'll subtract that from the hole, which is g of x, which is just the little line that makes up our whole. So we have the outer line, which makes up f of x, and our inner line makes up g of x. Okay, and here's our big radius, because it's the big one, and then we have our little radius. Okay, and then we're basically doing the same thing down here that we did over here. We're subtracting our big radius and our little radius. So we've just got the pi r squared times height thing. And yeah, so that's the disk method and the washer method. Hopefully I didn't confuse you more. And just let me know if you'd like me to attempt a problem.